Okay. So you read this question, right? That Sam is planning to open a restaurant, that serves Italian food, and you read it, right? Okay. So it says this: construct a 95% confidence interval for proportion of all the people. Let me get my calculator out. All right. Okay. So here we are. So tell me, where do I go for such questions? What do I do? Go to stat, right? Very good. Then where do I go? Tests, right? Okay. Louder. Okay, so don't worry about noting it yourself. It will be on the blackboard just as it is, okay? Yeah, everything will be on blackboard, all right? So let's just, yes, exactly. All right, so look at that and tell me that what do you think I should use? First of all, I should use a test on an interval at the moment. What do interval or test? I mean, they're all tests, of course. Interval also does a test for you. It also does estimation, right? So primary goal is estimation here. Do you see anything here that's helping us out? No. Okay. So we have more options, right? Okay. All right. So what would you say? A, very good. A, one proportion, Z interval. Since I'm not very good at typing and my finger is hurting, so I'm just going by arrows. Everybody good? Yusuf, how does it look, sir? See, I wanted a one proportion Z interval, right? Yusuf, you're with me, right? Okay, good. So I'll say this, right? Come on. Okay, good. So, how many out of how many supported a new restaurant like this? Yeah. Louder. 2 out of 312, right? What confidence level do we want? 0.95. We have 0.95 right there, right? Everybody clear? Okay. So we go here, we do calculate, and here is our interval, right? Everybody fine? Good. Very good. Hello, Nancy. Okay. So there we are, right? Makes sense? Now we have part B, all right? Okay. So part B is at least how large a sample must be taken to meet the target with this margin of error with a 95% confidence level, right? That's what the question is. Okay, Russell, am I clear, sir? Okay, so what do we do? You know this here, that there is no direct, uh, no direct calculation method by this menu that I could see. So I can use a rule, right? So when I use the rules, I go to manual, right? Our manuals. So here are the manuals, right? Okay, let's see. So is this chi-square? Yes or no? For example, well, it could be chi-square, but we got something easier here, right? Notice this. It's asking for the required sample size, right? Am I clear? Okay. Excuse me. Thank you. And excuse me again. Okay. Okay. This is asking for a required sample size, right? And sample size is, I mean, if I'm looking into the manual without much descriptions, it's n, right? Okay. So it says you can use this where E is the margin of error, which happened to be how much? 0.03 in here, right? Mary, it says 3% margin of error, right? Yusuf, if we are talking about proportions, 3% as a proportion is Russell, 0.03, right? Isn't it? Okay. So then we go right up here where I was, I forgot, right here. Okay. And then what happens? And P star is an educated guess, right? Jesse? Makes sense? That's an educated guess, right? That's what it says. Okay. So how do I get my Z star, the critical value for 95% confidence interval? I just take the 97.5th percentile of standard normal distribution. Everybody remembers that? Yeah, if you look at the Mary, 95%, then half of the tail, 2.5%, right? Everybody good? Okay. And excuse me again, okay? Thank you. So here we go. Who gives me percentiles of normal distribution? Inverse norm, right? And I'm looking at who? The point. Well, let me pull the calculator up a little. 0.975, right? And I'm not going to give it any parameters, so by default it will give me Z. So see, it says 1.96, right? Now we use 95% so frequently that you even have 1.96 committed to your memory. And if you use it like that, unless we are deciding something with a razor thin margin, you will be fine. All right? Everybody clear? Okay. So this is my Z star. Everybody clear? Okay. So I'm going to write these values in. So my Z star is right here. So I can say second answer, right? Makes sense? Divided by margin of error is 0.03. Close the bracket. All right, Julie, how I square it? Just say square, right? She's offended. Why did I ask such an easy question, right? That's okay. Everybody clear? Okay. Now, let's look at, now it says P star is a guess value, right? Now in here, notice I already have a guess value from previous sample. How much is this? 0.74 that you can use on this. But just to let you know, that if you want to be more conservative, which I'm not going to ask you to do on the exam, then people generally choose the value in the interval that's closer to zero point 0.5, all right, because 0.5 gives you a larger sample. But in here, I mean, you just use 0.74 if you would like, because that's consistent with the way your book goes. Okay? Yes, sir. Yeah, exactly, which is the same thing as 0.74. Thank you, Casimir. It's 95%. Yeah, 90 interval. You'll take the 95th percentile, Glory. If I'm using a 90% okay. As I said, inverse norm 0.95, because 90% means middle is 90%. The tails together are 10%, right? Half of the tail is 5%, so the area to the left will be 95%. All right, I'll do a 90% for you soon, okay? Because, okay, let me just, okay, that's very good. Okay, let's finish this, Jesse, then I'll justify 9.975 again, all right? Okay, so can I let's just finish this number, and then I'm going to say why did I take 0.975, right? Okay, so here, so we got this point, okay, and what was that? 0.741 minus 0.74. Everybody clear? So what do I get? 821.21, right? Or 0.22. Okay. So here is, our interval is right here. And then for the sample size, what answer will I give? 822, right? Everybody fine? I round up always in this case, because if I'm reading $821.22 for something, somebody doesn't give me change back, I gotta give them 822. So here are the people, they will be counted in the whole numbers, right? Everybody fine? Okay. Now let's justify very quickly that. Yes, this is the answer for part A, Mary. Okay, yes. And don't leave a sample size in fractions. I mean, you can leave it, but doesn't look good, and often some people may not accept it. All right, who was that, Mariama? Okay, makes sense. Okay. So now give me a moment. I'm going to explain to you reason for 0.975. Then Glory wants to know it for 90% and all that. So give me a moment. All right. That when you are looking for your Z star for a 95% confidence interval, right? What does that mean? That you are looking for the particular value of a standard normal variable, okay, such that this area is how much, Glory? And Jesse, this is your question, right, Jesse? This is 0.975, right? Jesse, am I making sense? So either tails, the two tails combined are what? 0.05, aren't they? Right? Okay. So the left tail will be what? 0.025. What the right tail is? 0.025, right? Everybody clear? So, okay, I don't know why I did that. Yeah, my index finger is not working today. So, yeah, this will happen. Okay, 5. Thank you so much for your kind comment. Everybody good? So, Jesse, please look this way. That is, if I am looking for the entire area to the left of Z star, because that's what the calculator, you know, communicates to us with, then the entire area is what? 0.95 plus point what? 025, right? So Jesse, does that answer your question then? Okay. Now, yeah, I'm going to do 90% for Glory. Then I'll do 99% for Mary, unless she says I got it. Okay, all right, that's okay. No, you guys are very kind. I mean, you ask me questions, and because you're going to do well on the test. Because if you don't do good on the test, my holidays will not feel that good. You know that, and I mean that, right? Okay, louder. Oh, you guys are the best. Okay, I want you guys to be the best. Okay. All right. Yeah. Okay. So go here and then go here. All right. So Glory. Okay. I don't know why I did that. I did something. Yeah, because I was answering question for Glory and I was thinking about Mary for some reason. Right. So that's why we went to 99%. Okay, Glory. This is 0.90. Right. Okay, Glory. So this will be how much? 5 cents, right? So what would I put in the calculator then? 0.95 instead of 0.975. Danish and Nancy, how do we look? Looks good? Okay, Mary, are we good? Sure? Okay, and now I have to answer the question for Mary. Okay, let's do that. Okay, let's look at this guy here. Okay, Mary, here. So there you go. There you go. The middle is 99%, right? Okay, Mary? So the two tails together are what? 1%, right? Am I clear? So what happens to this left tail? It will be half a penny even if they don't mint it, right? Okay? Am I clear, Mary? So this time I will put what instead of that? 0.995, right? Everybody in the room fine with that? Okay? Everybody clear? NS, am I making sense? Good. Very good. Okay. So let's do this. Let's go down to the next question. Okay. All right. Okay. So the next question is what was the next question? I closed it. I lost it. Okay. Good. So let's work on this then. All right. This question for Clara. Hello, Masuda. Good. How are you? Okay. So now, this is the question that we have to work with. Where did Yusuf disappear? He went somewhere? Okay. All right. So anyway, so everybody sees this here? Okay. Tell me, what do we have to answer for here? N, the sample size, as Julie said, right? Okay. Let's go to the manual. Here's the manual. Are we talking about this? Yes or no? No, because here we are looking at the sample size required for an interval for mean. Alan, do I have your attention? Paying attention? I'm not being dictatorial, but we may have to close that laptop, okay? Uh, no, I want you to be here. I mean, since you stayed here, all right? Okay, you can be at review sheet at your own leisure. Okay, all right? Everybody clear? Okay, so good. So where are we? We are right here, right? Everybody good? Okay. So we are looking at the for the sample size, that's connected with the sample mean, and here we go. Okay, that's what our manual. That's and you developed this manual because you solved that equation. Remember that? Yeah, who had solved it? I think Glory had solved it for us, or many, Glory and others, I should say, Glory et al. Right? So in here, give me the ingredients for 95% confidence. Who is the Z star? Quickly. 1.96, right? So this time I'm just going to go just slowly. 1.96. Who is sigma here? Is printed as sigma, but if it's not printed as sigma, what they will say? They will say that it's the population standard deviation, right, Russell? Okay, thank you. So that's 2.7. What's the margin of error that they would like to have? 0.5, right? So we got 0.5, and what do I do now? Louder? Square it, right? So how many people do I need in my sample then? How many? Louder? 113, right? Okay, everybody clear? Louder? Samira, you were talking and then you said something that I can't understand. What were you got it? That's what it meant. Thank you. So see, we are working on this question, right? Everybody good? Okay. So, Samantha, this question is asking us to do what? Develop a confidence interval for the population mean, right? And where the population standard deviation is given to be how much? 40, right? Everybody clear? Okay. NS, am I making sense? So I get my calculator. Okay, very, very quickly. So we are just assessing ourselves now. Stat, where do I go? Tests, right? And what do you want me to choose here? Ln. I want a confidence interval for population mean. I know the population standard deviation and the sample size is large. So which one will I choose? Very quickly, somebody, anybody? Okay, but on the exam, it's you who will have to choose. Remember that, right? Okay. So the sample size is Yusuf. Sigma is how much? How much did they give sigma as? Right here, just show and tell, right? 40, sir. Good. What is the sample mean that they got here? 69.70, right? Okay. And then what? How big was our sample? 50, right? Okay. All right. And then we wanted to calculate, and here is our confidence interval, right? Everybody fine? Good. So that's our confidence interval, right? Then it's asking us for the margin of error, right? Okay. So let me just put the answer right here because that's where it belongs, right? Okay. And I shall post these very soon. Okay. All right. Let's keep going. Now for the margin of error, you know that the sample mean is 69.70, right? Everybody clear? And which is right in the middle here. Okay, so margin of error can be obtained by doing simply what? Take any of the endpoints, right? Okay, which is like 80.787 minus, okay, just take the estimate, okay, and the margin of errors is what? $11 and what? That is the right end point of the interval, Masuda. Okay, very good, very good, very good. Everybody fine? Okay. Now, actually, since we are using the calculator, we are going kind of backwards. Okay. Why? Because notice this. We can calculate the margin of error this way, right? Remember that? Okay. And if you do that, you still get the same answer. Why? Because for 95% confidence level, 1.96 is your critical Z. What was the population standard deviation? That was a 40. Then what was the sample size? That was 50, right? And you still get the almost the same value except for some differences because of the rounding offs. And I'm not writing the unit at the moment, but make sure that we put the units on our answers. Okay, everybody clear? Okay, good. Makes sense? So now you can see the margin of error is $11.09. So they are asking now, in case I wanted to have a margin of error of no more than 5, how large a sample should I take, right, Russell? Go ahead, Mariama. You have 2 questions? No? Oh, okay, just stretching. That's okay. So in here, what I would do, I'll go to the manual. Okay, either I can solve for n, okay, if the manual looks too overwhelming to me, right? Okay, so this is the value, right? Everybody clear? Samira, are we good on this? So all I have to do is that I know one, excuse me, point, oh no, not that, 1.96, God bless you, okay, times 40, and what do I divide it by? What was the margin of error that we are desiring now? 5, right? Masuda, it was given in the question, right? Okay, so then we get that. So we need a sample of what size then? 246. God bless you. Okay. All right. So there we go. Everybody good? All right. So it is 246. Everybody in the room comfortable with this? Okay. Good. So let me save it so that I can post it for you after the class. Make sense? Now I will erase it and let's look at another one. Okay, good. So there we are, right? So in this case, let's look at this. So we are saying this, that something has been the first choice of 35% of the users, right, Alan? So you would like to test if the proportion has now changed from that, right? So when I formulate my hypothesis, null is what? Null is no difference, right? So null is what? The proportion still is what? 0.35, right? What the alternative is? That it is now what? It is now different from that, right? Yeah, not equal to, you said not equal to. Sorry, I didn't hear it, Julie. Thank you so much. So the alternative is that, right? Makes sense? Then we have this sample. So if we look at this sample, right? Then let's go here, go to tests. What are we working on here? Quickly, please. One proportion z test, very good. So, oh, I already have the same number centered here, looks like. No, don't go that fast. 0.35, and what's that? 112, right? And here what we got? 400, right? And alternative is this. So we will say, go ahead and calculate it for me. All right. So here we got all the ingredients that we need. Sorry, all the information that we need. Sorry, it's the output, not the input. Okay. So who is the test statistic here? The test statistic is who? The my negative 2.93. That's very good. Okay, so the test statistic is negative 2.93, and here is our p-value 0.0033. Alan, does it look correct? Is 0.0033 is smaller than 0.05 or not? It is smaller, right? So what you will do, reject the null, and you conclude, what do you conclude? That there is a good evidence, all right, that this proportion has now what? It has helped. The proportion has now what? Changed, right? Everybody good? Makes sense? Good. Okay, so you have lots of material that you can just see to to practice similar exercises. So do that. Okay, let's look at this guy here. Okay. So we have right here. Okay. So here we are comparing the attitudes of males towards helping in the household work in two different countries. All right, everybody good? In the country number one, it's like 12.6 hours per week, or yes, and in the country number two, it's only 3.3 hours, right? Are we clear, Masuda? Okay. So Now what happens is we have to develop a 99% confidence interval for the difference between the means, right? Everybody clear? We are not going to do two separate intervals. We have to look at the difference. So we are going to look at the universe of all possible sample differences, right? Okay, but the calculator automates that for us. So I go here, right? Okay, what are we looking for? A 99% what? Sorry, interval, right? Everybody clear? Okay, so let's see. There is only z interval here. We don't know the population standard deviation. The information pertains to sample. So I think here is our tool, right? To sample t interval. Alan, are you clear on this? Okay, good. So Alan, give me the inputs then. What do I say for x1 bar? What's the mean for the same? Look right here. It's written right here. 100. Oh, sorry, 12.6. It's not 100, right? Good. And standard deviation is 2.8. What's the sample size here? 41, right? Yusuf, give me these numbers quickly, please, sir. See, for country 2, the mean is 3.3, right? Standard deviation is 0.75, right? And what's the sample size? 30, 39. And 95, now instead of 95, we are using what? A 99% confidence interval, right? And we are taking more conservative approach of not pooling here, right? Okay, so good. So we say calculate. Okay, that's the 99% confidence interval here, right? So it's like the difference is anywhere between 8.08 hours to 10.52 hours, right? We say this is in hours, right? Everybody good? All right. It's a 99% confidence interval. Does it include 0? No, not at all. It's much, much far from 0, right? So what the interval is doing then for you is ruling 0 out as a value, Andrea. Okay, so 0 is ruled out, right? So that means what? That there is a significant difference, right? And the reason I said 1% because Matt, what? 99% was our confidence level, right? Okay, so level of significance, we just went towards the complement, towards the remaining here. Everybody good so far? Yes. Oh, because starts at 8, Glory stops at 10.5. And there's so many values below this before you get to 0, right? See, if I ask you, is 10 included in here? Glory, you will say, yes, it is included, right? Is 9 hours and 39.7 hours included in here? I think you will say yes. 0 is the value for no difference. If if there is no difference between the averages, Jesse, right? Then the difference between the means will have to be 0, right? If it is no difference, yes, you do that if you are looking at no difference between two parameters. Okay, very good. Good question. Very good. So let's this is a beautiful question, isn't it, right? So here what we are doing, we are testing what? Proportions, right? Am I clear? In two states, you read the question already. I think you have read it quite a few times, right? So here, whether the proportions are the same. Look at here again, Jesse, that there is no difference between the proportions, right? Versus what? That they are different, right? Alan, are we together, sir? Okay. So we are going to test this hypothesis at what percent level of significance? 5%. And here is the information. Okay. All right. So let's take this and conclude it real quick. Yeah, exactly. These are the types of questions that you may see on the test. Yes. Who is talking to me? Jesse? Sure. Okay, so look right here. So in here, one moment, I cut it too brutally. Alan, you have a question, sir? No, you're good? Okay, so here. So when I go here, what are we doing here? We are doing, help somebody quickly. We are doing two proportion z test, right? Makes sense? Now it says x1 and here I have the percentage, right? Don't I? Am I making sense? Okay. So what I would have to do is I'll have to change it to a number, right? Don't I? Okay. So let's change that to a number. Okay. So it's 0.57 times what? The total number, right? Am I clear? So we may say, okay, let's take this number as 683, right? Makes sense? Okay. So here this number is what? Let me decrease the font size here is to bring. What was that? 683, right? Okay, good. And oh no, that's okay. You'll recognize it, right? And then for the other one, it's 62% of what? Okay, so somebody gave me a value already. You want to go with 334. Okay, all right, go with 334 if you want, or you can put 333. Okay, what did you get? Oh yeah, I don't know why I can't even read today. 344. I'll take 344 even though it's rounding up, but it's just giving no difference, like more support. Well, we'll keep 344. Okay. All right. So let's see. We go to stat, tests, and as you suggested, we are going there, right? So we have 683, and then what we got? 1198, right? Then we have 344, right? And then we have 554. And alternative is what? Not different, right, NS? Okay. And here we will go calculate. Okay. So what do we get here then? Yeah, it will give you domain error if you. That's what I was trying to do on the test. Yeah, but it's. So pissed off because I could see an error. I know. I'm sorry. We did that many times in class, Andrea. I'm so sorry. Okay. Everybody clear? Okay. Good. So here we go, right? So what we are going to do here is you are going to reject the null at 5% level of significance, right? Everybody clear? Okay. If you use 343, since the p-value is very much close to the level of significance, you might get slightly different result. One moment, Casimir. Okay, you might get slightly different result, but the thing is, when things come to margin, you got to analyze more. Go ahead, Casimir. I marked you wrong. I will mark you right. Okay. All right. See, you keep saying to me you are a nice guy, and see, I did a nice thing to you. So you can't say that anymore, right? Okay. All right. Now we have to get two proportion z interval. All right. Okay, so here we go. All right, so we have the same thing, right? Except that And again, with 343, the result might change a little bit. So here what happens? We get what? We get this for the, right? So what happens here is, yeah, that, does this include 0? I have every answer to ask Glory this question. Does this interval include 0? No, it does not. Okay. Here you rejected the null, right? So the two are in agreement, right? Everybody clear? And Casimir, don't get upset. You're not upset. You're very kind. Let me just give computer rest for a second. Now here you're going to test the null hypothesis that the population mean is 60, right? Versus it is greater than 60, right? So Alan, is a right tail test or left tail test? Very quickly. Right tail. Very good. Thank you. And it's given to you that sigma is 15. Somehow you obtain that value, right, Yusuf? And the test will be based on a simple random sample of size 40 and the level of significance is 0.05. Okay. And we are going to talk about what? A probability of a type 2 error. Somebody tell me what is a type 2 error? Somebody very quickly. Type 2 is not rejecting the null. Okay, very good. Not rejecting the null. Oops, sorry. If, okay, when it actually is false, right? Okay, that is, so we are going to see what is the probability that we will not reject the null. That is, we will do all our calculation with this premise that the mean is how much? 60, right? Okay, when actually it's incorrect, right? That is, it is in the direction of the alternative. So how would our decision rule be developed in this particular case? See, our level of significance is how much here? 0.05, right? Everybody clear? Okay, so notice this. So how much is this area then? If this is 0.05, this area is 0.95, right? So notice this, this red region here is the rejection region, right? Everybody clear? And this blue region is the acceptance region, right? Am I clear? Okay. So what is our acceptance rule? That if we have this, if we get this value right here, this value, then we do not reject if the sample mean comes out to be less than this value, right? Eveth, is that good? Okay. So this value is what? The 95th percentile of the normal distribution, right? For the sample means of samples from a population with mean 60 and a standard deviation how much? 15, right? Now, we are talking about distribution of sample means. So, distribution of sample means will have a standard deviation of what? Sigma over a square root of sample size. Remember that, Mary? Okay, so let's get this value here. How do we get that value? We go to inverse norm. Very good. And we will say, well, 0.95. And this time we have to give the parameters because we are not talking about a standard normal. Okay, so this is 15 over how much? Square root of 40, right? Makes sense. So what is that? 63.90. Everybody clear here? Everybody fine? 63.90. Okay, Casimir, and I have marked it right as well, right, Casimir? Okay, thank you, thank you. Okay, so where are we? We are here, 63.9, 63.9, right? Good. So now we are being told that the actual mean is how much? 0.65. So, when do we commit a probability of type 2 error, Mariama? When we end up getting a sample with a mean less than 63.9, right, Samira? So we just continue with the same thing. So what we have to do in this case is that we have to find the probability of obtaining a mean less than 63.9. Yusuf, wake up. I know he didn't sleep for 34 hours, he said, right? Yusuf, are we together? Good. Okay. So we want to get that probability when the population mean actually is 65. So now we want to get the probability, that is the area, right, of less than 63.9, right? So what do I put for the lower limit then? I can put 0, very good. But if I can't think that I can put 0, I can put an unusual value also. 0 will give you the same answer, by the way, right? Because you know that everything is exhausted within few standard deviations of the mean in this case, right? Mary, are you happy? Yeah, she always feels happier with that one, right, Mary? Yeah. Now I will put 65, right? And standard deviation is the same. So we got what? 40, right? So what's the probability of a type 2 error in this case? 0.321 approximately, right? Everybody fine? Okay, that's very good. Let's do one more before we go. Okay, and which is everybody good here? Okay, so this is like when we are using only calculator, right? Make sense? Good. Okay, so then we have this, right? Okay, let's look at the last question that we can do today. So you have a printout with you, so I'm not going to go much in the reading only, right? Okay, so here, what we have, oops, okay. So there are three types, the blossom rates for type of, three types of tulip bulbs are being compared, right, Masuda? Okay. So we have this and they are planted under identical condition, okay, and then you have to see if there is any significant difference between the blossom rates, and the significance level is given to be what? 5%, right? Am I clear? Okay. So null is here. No, it doesn't really matter. Okay, there's no difference. And alternative is what, Jesse? That they have different, blossom rates, right? That they are. Russell, are we good? Huh? Okay, crystal good. Oh, I see. Thank you, sir. Okay. All right, good. So I go to stat. Okay, do you see any tool here who will help me out? No, right? Okay, so what helps me out then? Mate, very good. Well, thank you, Pamela. Okay, because she's saying first you have to give it as a table, which is matrix in this case, right? So we are doing the chi-square test, right? So it says, where are your observed value? They are in A, right? Okay, let's see if I put them in A or not. How do I test it? Go to matrix, right? Go to edit. Oh, just a second again. Sorry, because I want to make sure that I've entered the correct matrix, right? Edit, right? Okay, 98, 89, 110, 32, 40, 27, right? Everybody clear? And then the expected, and you already have the manual here to compute the expected values, right? Okay, that how do you compute the expected counts, and we went over that in detail in our previous video, right? Okay, so let's go back here and let's bring this guy back here. Okay, so let's quit out of here and say again tests, right? Okay, yeah, we are about done with. So I said okay, and we will say observed are in B, right? Everybody fine? Alan, how does it look, sir? Say calculate. So it calculates this for me. Now, unless I want to see the chi-square contributor for each cell to do further investigation, for this purpose we are done here, right? That is, see, my chi-square statistic is right here, 4.54, right? Okay, and my p-value is 0.10, which is what? How does it compare with 0.05? It's greater, right? So we do not reject the null, right? And what do we conclude then? That we cannot find any significant difference between the blossom rates. Jesse, does that sound convincing? Does it, Samantha? Thank you very much.